Hi, this is video number 3. What I think we're going to try to do is we're going to try to do this example about the SAT scores, and then uh, I'll end that video. This one will be a little bit shorter. It's video number 3, but this is an example of the kind of things you would do with the standard normal curve. So SAT scores have a distribution that is roughly unimodal and symmetric and are designed to have an overall mean of 500 and a standard deviation of 100. In any one year, the mean and standard deviation may differ from these target values by a small amount, but they are good overall approximations. Okay, distribution that is roughly unimodal and symmetric. That's kind of another way of saying it's approximately normally distributed. All right, now what percent of scores are above 700? Now, if we were to take a look at the normal curve that we get with the SAT scores, it tells us that the mean is about 500. So we would have 500 here, and the standard deviation is 100. So one standard deviation to the right would be 600, and then two standard deviations to the right would be 700. Now, what we want is the percentage of students that score more than 700. Now, that's going to be this area on the curve over here. Now, by the empirical rule, we know that there's 95% of the data that falls between plus and minus 2 standard deviations. Now that means there's 5% outside of that 95%. And since the curve is symmetric, we've got to share that 5% equally between this region and this region. So the region that we have shaded over here would be half of 5%, 5% over 2, or 2.5%. So the answer to A, what percent of the students' scores would be above 700? Approximately 2.5%. Now there are a number of other ways to do this, but that one seems to be pretty straightforward. And if you say, well, I think it would be better to do this, it's fine. Give it a try, and if you get 2.5%, I'll bet that your way is just as valid as this way. Now, part B. Between what scores do the middle 95% of the students fall? Well, we've already really kind of answered that question, because we said that between plus or minus 2 standard deviations, which is from 300 to 700, we'd have 95% of the data. So there it is. We would say between 300 and 700 would be 95% of the scores. Now, C, what percent of the students scored lower than 400? All right, now, in this particular case, we're looking for the percentage that goes to the left of the 400. I hope you see that 400 is 1 standard deviation below the mean. Now, by the empirical rule, we know that this region right here, let me move that over just a little bit. There we go. This region right here has 34% of the data in it, because remember, between -1 and +1 standard deviation, there's 68%. So half of that, which would be from -1 standard deviation to the mean, would be 34%. And that means that 1/2 minus 34% would be 16%. So we would expect 16% of the scores to be lower than 400. Now it says find the percentile for the score for the following scores. Well, for 500, it would be 50%, because that's the mean. Half below, half above 50%. Now for 300, I think probably I need to just erase this whole thing, and well, no, maybe I can move things out. Yeah, that's working. Okay, and we'll just erase all that stuff. Now also, let's take this away. Oh, look, that worked too. Okay, now 300. So we want the percentile of the following score. Now we want the percentile of 300. The percentile is another name for the percentage of scores that fall below that value. That's the percentile. So notice we've got 95% in this region. Oops, it should not go over into that last region there. There we go. 95% in this region, and we have 2.5% in this region. And so 95 plus 2.5 from here on up is 97.5%. So below 300 would be 100 minus 97.5, or 2.5%. I guess it would have just been easier to say it's 2.5% also. So 2.5% would fall below 300. 800. Wow. Okay. I'm not even sure I can get the screen to accept 800 over here. Well, let's do this. We'll just put this where it belongs over here, 800. Now, remember, and the companion, let's move this out. The companion one over here would be 200. Now, remember, 99.7% fall between 200 and 800. This keeps grabbing the wrong. There we go. So between here and here is 99.7% by the empirical rule. That means we have 0.3% to share between this region here and that region out there. And we want the score below. Well, half of 0.3 is 0.15. So we have 99.7 plus 0.15. That'd be 99.85% of the scores fall below 800. And the last one's 600. That's easy. That's 0.5 plus 0.34, or 84%. Okay. Now, that would be using the empirical rule. Let's see if we can find an example where we actually need to use the empirical table. Okay, here's the normal distribution homework. How about if we do number 20? It says, use table A, standard normal distribution, to find the proportion of observations that satisfies each of the following statements. In each case, shade the area under the curve that is the answer to the question. Now, we want to know the probability, or the proportion, of observations where z is less than negative 1.83. Now, notice they've shown you a standard normal curve here on number 20. So negative 1.83 would be right about there, and this is the area that we want. So to find that area, or the proportion of scores that fall less than negative 1.83, we're going to go to the standard normal curve, and we're going to look for negative 1.83. Now here's negative 1.8, Here is 0.03. And so we end up with 0.0336. So going back to that assignment, I think it's here. Yeah. We get 0.0336 for the value of that area. So the proportion is 0.0036. If we wanted to change it to a percentage, if they ask for a percentage, it would be 3.36%. Now, I'm not going to do any more of those for you. I'm going to hope that you'll do those for homework and or for an assignment. And so I'm going to say, and we're done.